Hello.
Yes, sir. Yes, sir. It's audible, sir.
Okay. Let us, okay. Let me share. Okay. I think there is some maybe some
Now
problem.
you have joined in two devices, sir. One device is audible.
Yeah, yeah, right. I just okay. Means I don't know why iPad is not okay connecting it to some problem is there, but I'm sharing the screen iPad and
Yes, sir.
I'm
Yes,
going to
sir.
speak through the iPhone. Okay,
Yes, yes. Sure, sir. Sure,
that is
sir.
better actually. Yes, yes. So now, can you just inform me whether you can see my screen or not?
Yes, yes, sir. Yes, sir. It is visible, sir.
Okay, that's very good. Okay, okay. So shall I start?
Yes, sir. Sure, sir. Sure, sir.
Okay. So good evening, everyone, and thank you so much for inviting me to give a a brief presentation on the carbon negative building materials. Well, you all know me very well. Okay, so there is no need of any introduction actually. Well, so we have been working, okay, for quite some time on the sustainability aspects. And low carbon materials is one of the concepts that falls in the sustainability criteria. Well, what is the now right now is being practiced at this point of time. If you see, it is nothing but about low carbon services. So wherever you go, what kind of service, okay, like it is now there is an attention towards the services that should draw minimum carbon footprint as possible. Okay, whether it is a carpool services, when we talk about the case like Delhi, okay, like a lot of initiatives is going on, even the major, okay, mega cities across the world. If you see the garments, even we are now talking about, okay, well, let us go on renting. Even you, I don't know, like, I mean, if you know, okay, like even most of the marriage and all, like, there is a initiatives going on, not to purchase a new one, but go for rentals. Okay. And similarly, the mass transport systems, like in many, okay, like the cities now, India is also moving forward in similar line. And and we are seeing now even the cities which is having 25 lakhs or 20 lakhs population are also coming up with metro trains. So that is a big, okay, like initiative, okay, towards low carbon footprint. And so how we are going to do actually, how we are going to maintain this low carbon services. So we need to produce, the products has to be of low carbon nature. Well, and like how we are going to do it, well, can be like you have to design. Okay, so the design flexibility has to be such that it need to address the low carbon footprint, the cost effective, then the technological feasibilities, then then otherwise, like you go ahead, okay, like suppose you need a technology which is very high level, but some parts can be of having less greenhouse gas emissions. Now, the question is ultimately we are again coming towards when we say that low carbon products, we have to develop a low carbon materials, and nothing but can be a energy efficient material, can be a recycled material, can be from a renewable sources, or you design, okay, like atomic scale that is being practiced, okay, by several, okay, metallurgists. And so that is what is required. Ultimately, we are dependent on the low carbon materials, and that is the need of the hour. Now, when you say the low carbon materials or the carbon negative materials, well, well, there are so many are there. So there are so many even articles are available mentioning about, highlighting about the carbon negative materials. Well, it starts from the grass-based wood. Okay, like wood is the like carbon negative material. Well, and then carpeted tiles from recycled plastics, maybe the biomass, maybe the olivine sand, biopolymers, the nanomembranes, so biochar, biocrete. So there are many such materials are there, which can be categorized into carbon negative materials. So now the question is, when we talk about the scenario for a construction industry, like why we are so much concerned about, because construction industry is one of the largest contributor to greenhouse gas emissions globally. Particularly with the Portland cement production alone accounting for 8% of global CO2 emissions. So we all know, okay, like the consequence of rising CO2 levels. That is nothing but the global warming, extreme weather conditions, sea level rises, and several other environmental disruptions. So that is the challenges at this point of time. Now, well, there is a like now demand and there is a like growing concern. Okay, is there okay like for environmental friendly construction materials, and that is very critical at this point of time with growing urbanization. Now everybody wants to live in a city. Okay, nobody wants to stay in a village or even a small scale cities. So that is the challenges actually. So the point is we have to now think about the material that is the concrete which need to okay to be designed as a low carbon concrete. So that is what is necessary actually. Well, you can see, okay, this chart, okay, like the pie chart is given by the Global Alliance for Buildings and Construction. So you can see like the how okay it is divided actually. So building materials and construction goes for about 11 percentage. Then building operations goes for 28 percentage. Then transportation goes for 23 percentage. Industry 32 percentage and other 6 percentage. This is the the building and construction CO2 emissions. So out of 8 percentage, that is the contribution of like as a whole, if we divide, so this is the way like we can divide. So well, building operation that is a not in our hand as a civil engineer actually. So so it is mostly like we have to rely on the HVAC part. Okay, that is mostly like the mechanical engineers and the metallurgist. So so they will okay work on this. Industry scale, yes, we have to take a lot of regulations in a industry level. And transportation, yes, we have to now go into the green transportation. So there are a lot of initiative have been done actually in automotive sector, and that can be applied to the when the construction sector. But one thing is in our hand is the materials. That's building materials that we are adopting at this point of time has to be selected very carefully. So that is the need of the hour. So when we say the carbon neutrality, okay, when we say the basics actually, so one is the carbon neutral, one is the carbon negative, and one is the carbon sink. Well, let us see what is this actually. Okay. Well, let us understand like what is a carbon neutral. Well, carbon neutral is nothing but your carbon emissions that is equal to the carbon removal. And net zero is nothing but a contribution to net zero emissions. So you can use the material, but your net zero emission has to be zero actually. So net zero emission most of the cases you must have seen okay like it is being applied to the buildings. When you say the green buildings, we say net zero okay green building okay net zero like so net zero is a kind of a suppose we are like no, nowadays like we are working on a net zero concrete mixes or net zero mortar mixes. So this kind of okay like wordings is coming ahead. And next is the carbon negative. That is you are contributing slightly better. That is removal of carbon from the atmosphere. So that is one step beyond actually. So your material is a kind of a storing carbon dioxide or absorbing carbon dioxide. Well, in whatever the form, it is fine, but it has to okay store carbon dioxide. So maybe for some time, or maybe like a lifetime, or maybe the initial okay stages. So whatever the case it is, if you can store or that we can say some percentage of carbon dioxide we are removing and storing okay within the system. So that is the advantage for carbon negative material. So same thing like what is carbon neutrality like? So one is a carbon emissions generated and minus reduced reduced plus compensated emissions. that is equal to zero. So at this point of time, we are talking about carbon neutral. Because as I told you, like the carbon negative is a challenging job actually. So we mostly talk about the carbon neutral. So you can see, you could have seen, okay, this kind of footstep, green color footstep is there in many of the products at this point of time. Many of the organizations, many of the seminars, people talk about a green like marked food. Okay, that is nothing but your carbon neutral plus. So if you can work on the carbon neutral plus at this point of time, that also will be a significant contribution to the society. Okay, so this is all about, okay, because I'm presenting this presentation like in several places. So so it is a kind of a mixed audience. Okay, so I have added a little bit more actually. So what are the strategies? Okay, like let us see what the strategies towards carbon neutrality. Okay, so when we say the carbon neutrality, okay, so there is a means report. Okay, like okay, let us target by 2050. At least okay, we can say each and every point of time, we will say it is carbon neutral. We will speak about carbon neutral. So what we have to do actually? Well, you have to do the one can be green innovations in materials design. Second is efficient materials processing. Third is enhanced use of naturally renewable materials and correct material screening. And fourth is use of recyclable materials in construction. So if we adopt at least these four, we can at least okay reach the goal of carbon neutrality, and that is that is being practiced. And let us see how far we can reach by 2050. Well, when you say the carbon negativity, all right. Well, it is little bit beyond actually, as I told you, like 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 what people are doing actually. People like lot of research have been is being going on, have been done also on the subsurface storage of CO2. And it is not about civil engineers, it is about lot many of like researchers across the fraternity. They are working on the subsurface storage of carbon dioxide. Second is CO2 mineralization. Well, this is started from the agriculturist. Actually, agriculturists were started okay using CO2 mineralization. Well, it is not new. It is an ancient, long practice actually. Is CO2 mineralization. Well, right now this concept is getting a lot of attention at this point of time. Even if you see some of our work, we are also working on the CO2 mineralization actually. And third is using CO2 in construction and non-construction materials. Now, what is this? Well, we are talking about like particularly the construction is considered. Now we are talking about the CO2 curing, carbon dioxide curing. I'm just giving an example actually. So can CO2 be used as a curing agent? So over the time, this is going to help in the storage of a significant amount of carbon dioxide, and that is called the carbon negative or carbon negativity. So this is the difference okay, between carbon neutrality and the carbon negativity. Okay, so there are strategies. Well, this is a more like interdisciplinary actually. So in an industrial scale, what is being done actually CO2 injected materials. You can see like uh, then gas membranes, derived nanocarbons, cryogenic processes, gas hydrates, activated carbons, chemical looping. So there are so many okay like methods are available towards carbon capture. Now, okay, sorry. Okay. So what is being okay like well this is little bit okay like what further strategies okay possible strategies towards carbon capture. Okay, so well, this is completely interdisciplinary. Okay, so there are many things. Okay, uh, can be adapted and is being adapted, and lot of research is going on towards carbon capture through many such processes. So these are the what I listed here, but this is not in our part actually. What is at this point of time is important for build as a civil engineer is the carbon mineralization process. Well, well, it is a process. What is the what is the basic concept is the carbon mineralization is a process of transferring CO2 into stable mineral on carbonate basis. So you are converting CO2 into carbonates. That is nothing but your carbonation actually. So there are several methods are there actually. That is accelerated mineral carbonation, mineral dissolution and precipitation, enhanced weathering, biomineralization, and direct air carbon capture. So any of the processes can be adopted, and that's what is is here. But everywhere the concept is you are storing carbon dioxide through the formation of carbonates. So, so this is a excellent thing can be taken up particularly for civil engineering fraternity startups. Okay, but I think if you see the Indian situation is concerned at this point of time, not much research have been done or is being carried out. Particularly the building sector is concerned. So we have to now take it. You have to take it up, take it up very fast on this aspect section. Then, okay, the next is the carbon mineralization through nanomaterials. Well, there are metallurgists. I have seen, okay, some of my colleagues here, they are working at a nano level. Like how, okay, like the level research or nanoparticles additions enhances the mineralization process. That is how you are going to make the carbon mineralization, the process faster as possible actually. And nothing but how it is happening. Well, it is the concept is simple. When you are introducing nanoparticles, it is nothing but about the faster kinetics. So if you can make your reaction faster, and that is going to help in the faster reactions, that is through the better reactivity of the materials, and that is going to sequester carbon dioxide and more effectively. So this is what about so I'm not going to spend time here actually. So what could be the objectives we can set at this point of time? So this is, I mean, I'm just giving an idea. Like we can focus on providing a clear understanding of the scale of environmental harm caused by the traditional building materials like Portland cement, which are energy intensive to produce and result in significant carbon emissions. So I will speak about in later slides like what is the consequence for a OPC. So understand the environmental impact of the construction. Further, one of the objectives can be explore the role of biochar and recycle aggregates in reducing carbon footprint. Further, one can explore the benefits and limitations of using recycled aggregates in comparison to traditional construction materials. So, well, I will tell you in this aspect, we have started our research at very limited output has come, but this can be still taken up in a large scale actually. So this slide I will just keep actually why the sustainable practices in construction is required because of the lack of time. So we know it very well each ton of cement produced we are consuming almost 1 ton of CO2 to the atmosphere. So that is the challenge actually. So we have to now act on it. And so what could be the solution actually? So one solution could be one can be the work on the biosector. So particularly for Indian continent, if you see the research on biochar based cementitious composite is very less, very less actually. So this we can take it up. So many of the institutes in India like IIT Chennai, IIT Bangalore, even we NITK also we many institutes in India now starting the research on the biochar. So I suggest the industry also at this point of time can take up, and there are a lot of research already available. Extensive research have been carried out in the other part of the world. So this gives a rough idea. So this is, you can see there is a, this is a Wong et al. So they have given a beautiful ideas about how biochar can be produced and what are their advantages and how they are going to capture the carbon dioxide. So this is a extensive report is available. So you can go through it actually. So next is the upcycling of the biomass. Well, every time, everywhere, I am just uh, advocating, particularly for a country like India, the use of biomass. Because 70% of our GDP is directly dependent on the agriculture. And we are agriculture economy. We are an agriculture economy. So we have a significant number of agriculture waste that need to be taken up at this point of time. And upcycling of those biomasses at this point of time is very much necessary. So whether it is a agro waste, whether it is a wood waste, whether it is a food waste, whether it is sludges, the manures, so everything comes under the biomass, and upcycling at this point of time is very important. So one such form or one kind of upcycling of this biomass is a biochar. Biochar as a construction material, lot of advantages. It is a CO2 sequestered material. Means it is a keep on sequestering carbon dioxide, and the production doesn't emit any kind of CO2 emissions. And if we really use this carefully, it can be a value added construction material. So there are a lot of advantages of a biochar, and it is already reported. Many literatures are there which already report. Okay, so this is again the similar thing actually. So so in this way, we can create a circular economy concept and the carbon neutrality. So so this is nothing but a cycle where we talk about a circular economy, and that will lead to the carbon neutrality. Okay, so there are many things when I so I'm just going a little fast actually. When you say the biochar construction materials, well, there can be many. Okay, I've just listed only three: biochar based cementitious composite, biochar based polymer composite, biochar based even asphalt composites. So so these are three major applications I've listed, but it can be n numbers of applications which can be led to a carbon neutrality as well as the circular economy. Okay. Second material, I'm just advocating about the CND waste. Well, it is at this point of time is the need of the hour I'm talking about. And it is, we should really thankful to Government of India, where all the smart cities at this point of time are being asked to generate a CND waste management plan. Now, if you see a city like even 5 lakhs, also if we declare the smart city, they are coming up with the CND waste management plans. So this is right time where we have to find a way and find a solution how effectively you are going to use CND waste, because this is going to give a tremendous tremendous contribution to the carbon neutrality as well as the practice the concept of reuse and recycling. Okay. So if you say this work we have done okay for we are doing for last 3 4 years. So this is a data that we have collected and we have plotted. Okay, so is a through a GIS. Okay, this is a map. So now you can see only few cities the CND waste generation data is available. So now what is the requirement at this point of time? Now this yellow portion has to be covered okay, throughout India. So that's we are writing emails to several governments, state governments, even the municipality corporations to, if possible, give the data of the CND waste generation. And that is the need of the hour actually. So 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 there is an estimate. There is an estimate like around 400 metric tons of CND waste is getting generated. But the challenge is uh, um, we don't have a right data. Okay, only few datas are available, and based on data, we are talking about okay this much contribution okay towards carbon neutrality. Okay, now so well there are okay some challenges when you use okay like the CND waste because what we have realized it cannot be used as such. It has to be processed. So well, processing needs some okay like kind of energy that we have realized, but but that is absolutely fine okay because at least the processing doesn't contribute significant okay CO2 emission. Okay. So these are the like if you say the tools and machineries we have checked okay with so many like the municipalities, so many like contractors. We have spoken to so many engineers. Okay, like how we are going to process. Okay, so these are the primarily okay like tools and machineries and as well as the processing technologies you need to use for make it a useful material for the concrete. Okay. Now, now the challenge, the one more thing is, well, now the there is a concept of like the concept is uh, uh, till date. Okay, till date, uh, most of the cities, okay, most of the cities in India, they practiced a linear economy with respect to the CND waste. Means the moment there will be CND waste, each and every particle used to be sent to the landfill. So that is simple, okay, like means they were not okay, like having any kind of responsibilities, no thinking, okay, just directly okay, sent to landfill. But right now, we have to now speak about the circular economy. Well, come on, okay, don't dispose, give it to us. Or there should be okay, there should be okay some legislation. So I will speak about that, which will make sure all these materials necessarily okay to be recycled. So that is what is necessary at this point of time. So well, there are okay like beautiful like graphs are available actually. They talk about how okay CND waste can be okay like used as as a beautiful material okay by practicing several concepts by practicing the waste management practices, the concept of reuse and recycling, and that is nothing but your like uh, concept directly okay contribute to the sustainability. But at this point of time, what is necessary at this point of time is we need to have a lot of data, that is the properties or engineering properties as well as the life cycle assessment of the material is very much necessary actually. And that will give us a confidence of using the this kind of material into the construction. Okay. So well, so now this is nothing but okay. Like when you say the circular economy and sustainability, there are two goals of United Nations the Sustainable Development Goals among 17. Two are talking about circular economy and sustainability. Okay, so what is the benefits? Okay, like okay, well, I will speak about okay, like this okay benefits because we know it very well. Like when we add biochar, what is the benefits? When you go for recycle aggregates, what is the benefit? But as I told you, we need to have lot more research to make to make it okay, like more confidently you can say yes, these are the definite benefits. Okay, at this point of time there are little research is available, but particularly in Indian subcontinent, we have to really do a lot of research for our climate, for our situations, for our conditions. Okay, so well, this is like what is the difference okay, between recycled aggregate versus traditional construction material? So this is nothing but okay, like uh, the challenge is if you don't process with respect to a traditional construction materials, the properties and when we say the properties, we know the compressive strength that is the only one okay benchmark for a, with respect to the concrete okay compressive strength is concerned is is found to be lower actually. Okay, so that is the one challenge, and second is recycle aggregate is little porous and more water absorbing. So that is has little consequence on the mixed proportioning actually. So there are some okay, this kind of okay, like some okay, like comparison okay, like we have made, but the last is important is recycle aggregate is more cost effective. If you source it locally, that is most important. Means it has to be a local available material, and that is going to offer you environmental benefits and significant benefit towards reduced carbon emissions. And and we have designed many okay like buildings within the NIT premises within this vicinity where we have used many local available materials, including the CND waste or the recycle aggregate, and we have claimed lot many credits from the lead. Okay, like that is many buildings as categorized even like from gold rated buildings, even silver rated buildings. Well, till now, platinum is challenging actually. You need to have a lot of money actually. So, so this is the advantage with respect to the traditional material if it is available locally. That is the only challenges. Okay, okay. So carbon life cycle of building. Okay, like I will skip it actually. Then carbon capture technology. Well, okay. So this is a common okay thing actually. And when we say the carbon capture technology, so this is a concept I think you may be knowing, or I will just speak actually. So how okay like when we say the carbon capture, well, one is through the CO2 diffusion. Okay. Second is through the CO2 permeation. CO2 permeation, and third is CO2 dissolution. Okay. And four is CO2 hydration. And fifth is CO3, that is bicarbonate ionization. And six is solid decomposition, seven is carbonate nucleation, and eight is carbonate precipitation. Okay, so so this is the actually stages how okay carbon dioxide like goes into the capturing stage actually from diffusion to the carbonate precipitation. So this is a pure into chemistry actually, and the this is the slide actually like you can see given by again okay like same author Wang et al. Where they talk about the when you are going to target the CO2 capture in the center. Well, there are several factors associated actually, several factors. Okay. Well, it cannot be possible actually in all the like all the aspects of a material. So you need to concentrate on a particular thing and target for my carbon capture or the CO2 capture what I'm looking for and target that and keep on okay working on the carbon capture. Well, then next is there are so many other materials are there. Just because I just okay like highlighted only two materials. So but there are so many other like one is biochar as I already told you, green cement or the concrete, then bamboo and wood based materials, then even mycelium based materials, the bamboo and wood based materials, recycle aggregates. Still there are many are there. Okay, which now comes under the carbon negative materials. Okay, well, last is last is last is the what are the challenges? Well, this is the challenges and barriers to adoption. Okay, like that we have to speak about also is the building codes. Well, we don't have any building codes at this point of time, which can accommodate the carbon negative materials. So we have to now work with the government and we have to ask them make the codes and define okay like yes for any construction the carbon negative material has to be 50 percentage. So at least if it, that kind of standard regulations will come, we can really okay like will be easy okay and to work on the carbon negative materials. The second is supply issues. Well, as I told you, till date nothing is streamlined. If you say any material like for example a recycle aggregate, there is no streamline process is there where we can say yes, if I go to this plant to get a recycle aggregate, I'm going to get this quality material. Okay, so this is same thing for the biochar. It is inconsistent. So we have to work now. Industry has to work on a large scale projects. So upcycling, okay, like as I told you, like, it's very much necessary, and we have to work also for large scale construction projects. And last is the performance concerns. Performance concerns is, I would say, at this point of time, there is no solid data is available, but but we have to okay, like focus more and more for making a definite trend or definite results that will give us confidence on using this kind of materials. So that is at this point of time is very necessary because performance there is a concern. Okay, so these are the challenges and barriers to the adoption in my point of view. So with this, so this is like I went a little fast actually. So some references that like I've listed here, and but it is these are not the only ones. There are means I would say thousands of like articles are there on the carbon or like negative materials, and particularly at this point of time, I can see the construction sector, particularly like the construction sector or the researchers working in the building materials, there are a number of articles are coming up. So hopefully, okay, this will take it forward and we will achieve our goal by 2050, at least the carbon neutrality. So with this, I am stopping my presentation and thank you like for inviting me and I'm really happy like I could able to deliver okay like a small presentation. Hope this helped you.
Thank you very much, sir. Participants, if you have any questions for the professor, you can ask by unmuting yourself, or you can mention in the chat box. Okay, sir. I think there is no question. You can stop sharing, sir.
Okay, okay. So what I will suggest you, like you can means you can note down some of their research. Okay, but
Sure,
if
sir.
any active researchers are there, and if they have any questions, well, I would say you can note it down and you can mail to me also. Okay, and we can have a research, we can have a discussion either in the social media or in the mail, and again, okay, like there will be like there will be a kind of a communication which will be active. Okay.
Sure, sir. Sure, sir. Actually,
Yeah.
we will send a feedback form. Along with
Yeah.
that, we will send you your details as well, sir.
Absolutely. Absolutely. Yes. Yes. Okay, Dr. Savanan, thank you so much for inviting me. And so with this permission, I will like stop it here. Thank you so much.
Sure, sure, sir. Thank you. Thank you very much, sir.
Thank you, sir. Thank you so much.
So for the next session, is it visible, Lokesh?
Yes, sir. Visible, sir.
Yes, fine.
We
So
can, sir.
good evening to everyone. Myself Sharavana. So I welcome once again for the second session. So actually, on behalf of Innovel, we are hosting webinars on sustainability related topics every month. So this is our webinar pathway so far. So every month we are planning it, and we are focusing mainly on carbon reduction and low carbon based building materials. Since we are focusing on construction sector, we limit ourselves with construction related topics. So this is our so far webinars since April month. So currently we are in September and we are having our session. The next month we are planning for net zero carbon building design strategies. So based on IGBC perspective. So what they are suggesting, and recently a couple of days back, United Kingdom has launched their standards for net zero carbon buildings. So, if possible, we would cover that as well in our next month webinar, which would be positively held on 24th October, same time, evening time. So, and we would like to say that hereafter our webinars will be free of cost only. So there won't be any fees for any kind of category of participants, be it industry professional, be it a faculty or student. It's going to be completely free hereafter. So this is our Innovel's profile. We have started in 2013 and we are in 2024 with 100 plus members. And we are having offices across India based at Sivakasi actually, head office. Then in Chennai, Bengaluru, Hyderabad, and in Bangladesh as well. So this is our, top hierarchy and our beloved director, Gunasekaran sir. And actually, we are lead proven provider certified consultant for green building design and certification, especially for lead based. And obviously, we are certified by EcoVadis and we are ISO certified. And these are our services profile. We do design and consulting for NEP and BIM and as well as for sustainability. So under sustainability, we are focusing on green building certification mainly. Along with that, we are also extend our consulting for low carbon solutions, especially for interior projects and new building construction. And obviously, with regarding LCA, we are expanding our services as well. And this is our, short abstract about our experience. And we are for our Indian clients and foreign clients. And our office at Sivakasi is itself a lead certified for, existing building and operation maintenance. So with the maximum of 97 points. So we are, practicing what we are preaching, right? So this is our entire contact profile. If in case of anyone from academia want to make a collaboration with us, okay, you are, heartily welcome. And today's my session is going to be about what is simply carbon negative materials, uh, general characteristics of these materials, and what are the limitations and advantages. Then we will get to know how to develop carbon negative materials in case of in context of buildings. So then we will see about Indian case studies and we will conclude it. So regarding the introduction, I hope Professor Sir gave very broad and very important sharings about what is low carbon and all those things, so that we can skip those content. And this is it. The data matters. So emission contributes by the construction sector alone stands up to 38 percentage. So that's the reason why we are talking about low carbon building materials, and the CO2 trend is keep on increasing every year, so that we are concerning about how we can reduce the emissions accounted beyond behind production of construction based materials. And we have some visualization how the carbon is flowing across the built environment. So initially it is in the embodied carbon range, then it is becoming operational carbon range. So various stages are there, being the reason for embodied carbon as well as operational carbon, and everything together we are calling it as whole building life cycle carbon. So whatever uh, the technology comes, it approaches this context in a whole building life cycle perspective, so that we can accurately reduce or accurately measure the carbon footprint of any building material. So be it already existing one or being developed as a new one. So how and all we can reduce it? So there are different aspects and possibilities are there. In case of embodied carbon, there are some rules. During the construction and installation, we are having some options, and during the operation usage phase, we are having some options. So how our carbon negative material concept gets linked with these scenarios? So it is like carbon sequestration. So during the embodied carbon stage, we can imply it in case through R&D intervention. Then we can prefer those carbon negative or carbon neutral material during the procurement. And obviously, during the operational stage, certain advanced carbon negative materials are there which are capable of sequestering carbon throughout its life cycle. As Sar mentioned, so carbon mineralization, right? So the material which is continuously getting exposed into the atmosphere, absorbs the carbon dioxide and becoming carbonate. So that's the nutshell of CO2 mineralization. So what our soil is, doing, why people are treating soil as, fertile, non-fertile, because of that, minerals only, provide available minerals in the soils. How the minerals comes into the soil? So one among the reason is they are capturing the CO2 from the atmosphere. So in the same way, the materials are enabled to absorb the CO2 from the atmosphere. So that in that way, we can connect carbon negative materials in among all the three stages. So if you want to know what is the definition, so the materials that sequester more carbon than was emitted during their production. So understand, so there are different life cycle phases are there. Only during the production, how much amount of carbon is emitted, the same amount of carbon, if the material is sequestered, then it will be carbon neutral. So if it sequesters more carbon, then it becomes carbon negative. So in this context, one other important terminology is biogenic carbon. So I just want to leave this term biogenic carbon. for the participants. So you please go and read what it is. So get to know about it. So why it is important in the context of carbon neutral and carbon negative material. So if you list down some common or whatever the available carbon neutral and carbon negative materials, so these are all the common characteristics. So like attributes, properties, you can say. So what's the first one is biogenic carbon sequestration and long-term storage. So majority of the carbon negative materials which are being talked in current times are actually coming out of biogenic carbon concept, which means it is based from vegetation, like if it is in a biomass or it could be a wooden product or it can be an agricultural waste, right? So that's the very first point. Then utilization, renewables and waste byproducts. So the second common attribute is it is made use of any waste byproducts, preferably from bio-based waste byproducts, and obviously from industry-based byproducts also people are developing carbon negative materials. So second attribute is circularity, right? Third one is low energy production and local sourcing. So that's what another very important, because when you want to reduce the production carbon footprint, obviously you got to source your raw materials from the nearby locations. So all the carbon negative materials which are going to be, what to say, the top of the market, they have been come across that low energy production. Then fourth one is circular behavior. So as I mentioned, the material is being circulated into the value chain again and again, you know, to the maximum possible number of times. So that's the another common property you can able to see. Then finally, enhanced performance and environmental transparency, which means in the market perspective, when you talk about a newcomer in a carbon negative material, it comes with the recognition. What kind of recognition? Either it comes with eco label certification or it comes with EPD certification. So once they are having these kind of certification, we can able to understand, okay, they are authentic and they are trustable, right? So nowadays, whatever the low carbon materials being introduced into the market, they are well known and they are becoming popular only because of their authentic the reliability. So these are all the five different factors which are commonly being noticed among all the carbon negative building materials, right? Then what about the advantages and limitations? So obviously reduced carbon footprint, then sustainable resources. Advantages and all we know, because for that only we are developing carbon negative materials, right? Then in case of limitations, the availability matters, right? So not widely available or scalable for large projects. That's being one of the very much limitation, because for example, if you consider Indian context, we use lot of bricks, we use lot of concrete, then we use lot of steel, right? So these major three materials are there. So in case if you are asking, is there any carbon negative materials are there for these three materials, it's very, very rare and limited. So how many manufacturers are there in India to produce concrete or steel or brick in carbon negative value? That's a very big question mark. So the scalability becomes a very, very concern. Then higher cost, because the production process may need to follow a new pathway, right? So it's not following any existing factory setup or any existing machines or equipment. So that we need to make a full-fledged and whole new setup for producing such carbon negative materials, whether it be it in a R&D lab or in a normal production factory. So everything has to be set up so new, and we have to go beyond borders to procure all those equipments and tools. That's the very big challenge. Then performance issues. The thing is, We are now only talking about negative building materials, and we are having very few real case studies here and there across the globe. I am talking, right? So we don't know, or we are not having enough amount of performing case studies across the globe for different climatical conditions with respect to these carbon negative building materials. So it's like, initial period, people are hesitating, hesitating phase we are in. So that's also becoming a important limitation with respect to carbon negative building materials. Then how we can develop these materials. So what are the three short and very important pathways to go for R&D on carbon negative building materials? So okay, why being an industry consultant, why you are talking about the development of R&D? What's the connection? So people are here, from academia and research background, they can able to do it. How they can connect with us is they just need to go some steps beyond their R&D labs. So they just need to go for Green Pro certifications or GRIGA certification, domestically. So if you go for international market, because IITs are having campuses, in different countries, and different other country campuses are going to be normal in Indian campuses. So it's not going to be anymore Indian person or state-wise R&D ability. It's going to be global. So when you are doing your R&D in your lab, you just need to go some few steps beyond your compound so that your product can go to the market actually. So for our today's topic, we can talk about Green Pro certification, GIGA certification, eco labeling, right? So like a green product. So once you get such a certification, obviously you can roll out your R&D results as a what to say debutant material into the market. So people will buy it, or they will at least suggest it. So this is how we as an industry consultant want to extend connection with the outsiders. So these are the three ways through which you can develop your carbon negative building materials. The first one is biogenic carbon sequestration. You should get some agro-based or bio-based component so that you can process it and you can make some material out of it. Second thing is carbon capture and storage. So that's a different domain and concept where the emitted carbon dioxide from the industry, that exhausters are being captured and converted into solid carbon or liquid carbon or gaseous carbon. So that has to be obtained, and that carbon has to be incorporated into your material development so that you are arresting and locking down the emitted carbon dioxide into your building material. So that's the second pathway. Third one is waste utilization and recycling. So by utilizing large amount of waste material, so like recycled content, people used to say in industry. So how much recycled content is there in your product? 10%, 15%. So when you want to make more than 50%, 75% of waste content into your new material development, obviously you can develop carbon negativity out of it. So considering the baseline material development and your proposed development, obviously you would grind down into carbon negativity. So, for example, for each methods we can have for the biogenic carbon, Chemcrete is there, laminated timbers are there, then straw bales and straw panels are there. So straw, all those things are, that vegetation based, like what to say, biomass based. So that and all are highly, natural material, and you will get your carbon negativity eventually. Then the second concept, carbon capture and storage is there. We can talk about biochar enhanced concrete as professors are described about it. So those biochar is like uh, nothing but burnt biomass, right? So incinerated biomass, we can say. Pyrolysis, subject to pyrolysis, and you can capture the biochar in a solid form. And those biochar can be utilized into your concrete mix or whatever the raw material mix you want to make into a component, whether it is in a concrete or a brick or any other material. Then biots are infused building blocks. So that's what I just said. The third one is for waste utilization recycling, we can have agrocrete, concrete, mycelium based materials, and biochar based insulation panels. So in this way, we can understand biochar comes under the carbon capture route also. Also coming under waste utilization also. So both way biochar comes into the play. So that's why professors have described more about the importance of R&D of biochar in the development of carbon neutrality materials. So here's a glimpse. It is actually from Autodesk. Autodesk is actually providing our very famous softwares. But they, as a company, they are into their R&D about how to reduce their own buildings' carbon footprints. So out of that, they have come out with some material development out of the waste products. So that's the glimpse. So what they are doing is they gathered some agricultural byproducts, waste products, and they are having cultivated mycelium. So they are mixing both together into a mold, and once it is grown up, it becomes a carbon negative core. So why it becomes carbon negative here? Actually, when the mycelium is getting inoculated and being under the incubation period, it absorbs continuously the atmosphere CO2 and it locks down into the roots, and mixing with the agricultural waste, it becomes a solid stuff. So that's what finally you are seeing. It's like a cake. So what they are calling, that's a carbon negative core. So that core is being obviously after some post processing and some finishing, it is being tested for thermal conductivity and thermal related properties and strength related properties. So once it is being done, what they are doing, they are sandwiching that carbon negative core in between two glass fiber reinforced polymer plates. So what they are telling, that glass fiber GFRP has some positive carbon footprint, and the core has some carbon negative footprint. So both together nullify the carbon footprint, and finally you are making a carbon neutral building material. So that's what they are proposing, and actually they are using that as their building's facade element, right? So you can able to see in the last picture such sandwiched core is being installed around their building as a insulation facade. So this is what people are doing across the globe, and I hope this gives you some idea. So here the matrix shows that what is the existing core. It's like polyurethane core and expanded polystyrene core, actually plastic, right? So both of them having some more amount of carbon footprint, but our mycelium composite core is actually carbon negative. So obviously that helps you to develop some carbon neutrality, right? So here are the Indian case studies, carbon tiles. It's a very interesting case study because these carbon tiles are handmade. So there is no machineries or there is no external energy are being invested in the production of such tiles. So what they are doing, so they are carbon black from waste tire recycling plant. So it's being mixed with marble waste and binder to handcraft your tile. So we can say first carbon negative tiles in Indian market. So understand it's a tile, right? There is no block or any masonry stuff. It's a tile. So flooring tile and walling tile. So they are claiming that their tiles are suitable for both interior and exterior. So how much amount of carbon they are, sequestering? 20 millimeter thickness of 20 centimeter cross 20 centimeter tile can prevent 5 kg of CO2 emission. So how it becomes carbon negative? The emitted carbon black from the recycling plant is being captured and stored. So that's what I told, carbon capture. So those captured carbon is being utilized as the major raw material ingredient for the production of these tiles. That way, this becomes carbon negative. And understand they are doing it in a handcraft manner. So what is the logic behind handcraft? What's the need actually? So we all very known that there is a very famous car company. Their engine is being handcrafted, handmade. So only for that the purpose, the car is being sold for crores and crores of rupees across the global market. I actually forgot the name. So that's the fact. So when we are going behind some machinery based ideas and fast production, but that car company still sells their value proposition with respect to their handmade engine. So the same way this particular company might have got inspired, but what they are telling is we are giving chance for the part makers. So I hope all of us know who part makers, right? So they're almost got vanished. We don't use part makers. Even we nowadays we are having part kind of plastic bottle, right? So to hold water or to like water can or water container in our home. So they are telling that we are giving chance or re-chance, another chance to those kind of artists, in the local neighborhoods. So they are telling it as, carbon reducing strategy. So at the same time, that strategy gives employment to the handsome amount of persons. So that way they are claiming it as a very, very important thing. So these people are, keep on expanding their R&D, and they are already Green Pro certified, and the product is VOC free and ROHS compliant. ROHS in the sense there is no hazardous element is there present in the product, right? So this innovation is actually happening in Bangalore plant, right? So they are having a plant in Bangalore. Earlier they were in some North Indian face in Mumbai or Pune. So recently they have shifted to Bangalore, and they are expanding their market to nearby countries like Singapore and Australia as well, right? And the very another important thing is Agrocrete. So world's first carbon negative concrete block, right? Yes, world's first, right? So where it is located? It is located in Visakhapatnam or Vijayawada. I don't know exactly. It's in Andhra Pradesh. So they are having the plant there, and they are doing manufacturing and exporting across the globe. So comparatively, we can understand the impact in both in the cost and as well as in the carbon footprint. So we have fly ash bricks, we have clay bricks. Apart from that, what we have AAC block. So this Agrocrete can replace all the existing stuff in regarding cost as well as carbon footprint as well as strength parameter also. So in this way, Agrocrete is being a very, very important product in Indian market, and they are actually carbon negative. So what's the raw material? Processed crop residue fibers plus low carbon mineral binder. So that mineral binder is also patented, and that processing with the crop residue fibers also patented. So with a single product, they are having two different patents, and they are make that makes their product so unique, right? So as much as possible information we can get it from their website, but obviously that intellectual component alone we can't able to access. So upcycled material made from crop residues that would otherwise be burned, making it carbon negative. So we might have heard that stubble burning in Haryana, Punjab, right? So every year that smoke comes into the Delhi and makes smog issues on that. So those kind of agricultural byproducts they are preferring from the local fields of Andhra Pradesh, right? So they are utilizing it so that they are preventing carbon emission as well as they are capturing the carbon emission as well as the crop holds some significant biogenic carbon potential. So 3.5 times the thermal insulation, half of the cost and same strength compared to AAC plus. So it's actually evaluated and approved by CBRI. So and they are also third party verified EPD available, right? So EPD certified world's first carbon negative concrete block. So you may wonder why not America, why not UK? How Indian can become world's first concrete? So it's very simple. Western countries don't rely much upon concrete stuff. So they mostly rely upon wooden based structures, right? So based on their existing climate. So that's why India holds that tag. Obviously, there is no Chinese product, so that's a very good sign in that sense, right? The third one is Agri Bio Panel. So this is an interior wooden based product which are actually made from 90% straw and binding adhesive. So these straws are actually again agricultural waste byproducts. So they are mixing it with some patented adhesive and they are high compress it to produce such panels. So these panels are having lot of positive properties like they are carbon negative, fire resistant, moisture resistant, termite proof, and providing insulation also up to 40 decibel and obviously UV resistant. So they are actually the product manufacturer is structure, eco structure or structure, I think. So they are based out of some South India only, but I am not exactly know the location. So they are offering lot of positive properties to the product. So because this product becomes very much significant in case of interior design. So a lot of IT companies are there having lakhs and lakhs of grass floor area doing multiple numbers of batches of interior design project every year. And new IT complexes are being built. So for example, we can have some IT complex in Hyderabad, Chennai and Bangalore. One single block comprises of some 4 floors alone comes around some 6 lakh plus square feet of grass floor area. So that much large area I wanted to mention. So for the entire area, they will come for interior design project, and for that they would like to get some green building certification also. So in that case, these kind of products would become highly important for them. So not sacrificing the aesthetics, not sacrificing the comfort of the occupants, but at the same time contributes to the low carbon and increasing the brand value. So this particular agri biopanel is very very important in that sense. So these are all the sample carbon negative materials, building materials available in India. Apart from these, several materials are there which are still in emerging phase, which means they are not yet get their Green Pro certification or any environmental recognition like declaration, product declaration. So once they are getting those certifications, obviously they will become into the limelight and we can able to assess them. And finally, these are the key takeaways I could be able to say from this webinar, along with our professor's session. And this session, I hope some knowledge exchanges have been made, especially in the domain of carbon neutrality. So carbon negativity is fine, but still we can invest more on achieving carbon neutrality. Because once you achieve carbon neutrality, over the time you can optimize your production process or you can optimize your supply chain, and obviously you can reduce your carbon footprint and you can make your product carbon negative. So that's the ultimate idea. So thank you. If you have any questions, you can ask now.
Hi, I do have a question.
Yes, please, sir.
Yeah, so I am currently working on a project where we recycle textile waste into construction material with the help of mycelium. So, I
Yes,
mean,
yes.
as part of this project, I am also, the end goal of this is to make this product which would be eligible for lead credits. So I'm not very thorough about how the system of lead credits work. So could you please explain me, when an architect or a engineer, when they select products which are lead compliant, how do they choose such materials? What are the challenges which they face?
Yes, actually, two simple metrics are there. One is recycled content. So, how much recycled content your new product holds. That's the first point. Second point is whether your product is free from VOC emission and whether your product is free from hazardous element. So, for the first one, recycled content, uh, you are advised to go for LCA. LCA in the sense life cycle analysis of your entire product. Like simple LCA report from an authentic consultant is enough. But if you want to more some recognition kind of thing, you can go for Green Pro certification. I hope you are from India. In case if you are India, you can go from Green Pro certification. So in case if your work is scopeful in some other country, so your particular country would hold some green eco label certification. So in every such eco label certification will have LC as a internal component, right? So once you have that LCA, that recycled content will be satisfied. So for the
Okay.
next one, VOC free and hazardous element free, you should get ROHS compliant. So that's what industry people will simply mention. So ROHS, it's a kind of certification body uh, which are focusing on such elements, right? Mainly used in interiors. And in another certification is also there. I would like to convey you. There's a well certification. So if your
Well,
construction well, WELL, so they
okay.
are actually completely focusing on the internal environmental quality with respect to the used materials, right? So you please go through what they are suggesting, and there in well only that ROHS compliant it becomes very very important. And one
Okay.
more thing is there regarding the emission. Some California Air Emission Authority, I think. So they are certifying the products based on their emission categories, E1, E2, E3, like that, they are categories.
Okay.
So if you notice that our agri biopanel is E1 certified, which means they are emitting very, very negligible amount of emissions during their life cycle, which is not harmful to the occupants. So these are the certification you might require.
Okay, got it. Thank you. And regarding the LCA which you mentioned, if I would go forward with LCA in India, roughly how much would that cost me?
Casting is very very different. So there would be different ranges of consultant. So very emerging consultant which are they are just launched in market. They would
Mhm.
do the same LCA for you for some 50,000, right? So but if you go to some very big consultant, they can ask you up to 2 lakhs or 2.5 lakhs per LCA, right?
Okay.
So it's totally up to consultant. There is
Okay.
no like range. But
Okay.
there would be some registration cost would be there. In case of Green Pro certification, if you go,
Mhm.
that and all are basic application fees, processing fees. Apart from
Mhm.
that, they are charging some consulting fees, right? So that's what would vary, and all other fees would be equal, everywhere.
Okay, got it. Okay, so my third question would be: let's say that I'm an engineer who is trying to build a LEED certified building. So now I have a list of materials for me to choose. So how will, I mean, most of the materials have its own credits mentioned in the list, right? So how do I particularly choose the right material for my building? Because some of them, even though the credits may seem nice, but performance wise it wouldn't be equivalent enough. So what are the challenges usually architects or engineers face
Yes,
from that
actually,
perspective?
regarding the material choice, in lead itself, there will be life cycle assessment, impact reduction categories is credited.
Hmm.
So, what people will do, you as a builder or a client, you will share your bill of quantity details. So, these are the
Hmm.
materials that I want to use, like that, and this much quantity I want to use. So they would, perform building LCA. So likewise, product LCA, there is also called building LCA. So
Okay.
when they are performing the building LCA, they would compare baseline condition and proposed condition. So baseline condition in the sense, whatever the material that you are giving, that they will feed. And in proposed condition, they will alter the material choices between option A and option B. So in the software, there will be tremendous amount of options will be there. And based on locality also, you can choose from. So if it is in India, if it is in America, if it is in some France or Germany, everywhere you can choose the material. Or at least from the nearby countries, you can choose the material. So based on that, they will tell you the overall building's carbon footprint with respect to the material choices. And they will distinctively tell which material contributes more. So based on that result, you can understand and you can choose from, okay, this material is very important for me, so that I'm not going to change it.
Hmm.
So what's the next option? Likewise, you can go through the results and interpretation, and you can obviously make the better choices, which would eventually help you to reduce the carbon footprint. And that carbon footprint is actually part of LEED certification. They will award the credits accordingly.
Got it. Got it. Okay, thanks a lot.
Yes, yes, fine. So I hope the sessions were, very good for all of you, and we have shared the feedback a form link in the chat box, and we will share the same through the mail as well. So I request all of the participants to submit the feedback form, and after that we would send you the webinar certification as well. So thank you everyone for the day. Lokesh,